Hey everybody, welcome back to this Fundamentals of Sequencing series. So this is episode number 6 on mc.midiplayer, which I know a lot of you have been excited about. This is kind of an important object because it is the thing that allows us to turn the sequencers that we're making in Max into MIDI, which is a very valuable thing. If you're some of you may be making your instruments in Max, so you may be making synths or samplers inside of Max, which is super cool. But if you're not doing that, and I often don't, and you want to be able to talk to a synth that lives on your desktop or in your DAW, you're going to need to be able to send some MIDI. It also has the capability to be able to control VSTs that you host inside of Max using the VST tilde object. So if you use plugins and you want to actually run them directly inside of Max rather than inside a DAW, mc.midiplayer can help with that as well. So we're going to kind of do a deep dive into this object today, talk about how it works, how to use it, and then at the very end actually talk about some other ways to do what it does in situations where maybe it's not the best tool for the job. So starting off just with a quick overview of the object. 3 inlets and 2 outlets. And the inlets are, the first one is where we send in a signal that will basically tell the object when the MIDI note or when the note event starts and when it ends. And by default, that's expected to be a ramp signal like this. The second inlet is for a signal that represents a pitch as a MIDI note, so some value between 0 and 127. And then the third inlet is for the velocity, which is actually in the range of 0 to 1. So you can see here by just clicking the K slider, I'm creating these signals. And you can see what I'm doing over here is I'm using ramp object, which I talked about in the last video. I'll put the link up above, to give myself a note that is of 250 milliseconds in length. And by just hooking an integer box up to that, you can then change the length of your ramps and make your note events shorter or longer, which is really useful. On the outlet side, there are 2. Right now we're using the one on the right here, which gives us this MIDI event message. And this is very easy to turn into raw MIDI that we can just send to any MIDI device via the MIDI out object. So the way that we simply do that is just use a route object to remove the MIDI event bit, and then use an iter object to turn that the rest of the list, the rest of the message, into separate messages. So you see, as I click things here, we get 6 in a row, and really it's 2 groups of 3. So the first one is the note on event. So we generated a MIDI note at note 57 with a velocity of 13, and then 250 milliseconds later, we generated a note off event for that same MIDI note 57. And these 144 and 128 basically are MIDI E's for note on and note off events, respectively, on channel 1. As you can see here, we're also passing that raw MIDI into a MIDI parse object, which interprets that information for us and just gives us, from its first outlet, those MIDI note messages. Okay, so let's now move to this next tab and just show this same bit of patching. So everything down here is the same, but show it with a little sequencer in action. So what I'm doing in this particular case is I have a stash object that is storing some values between 60 and 71, so MIDI note values, which is being driven by a phaser, which is my clock. And then from the left outlet of the stash, I'm just passing that MIDI note value directly into mc.midiplayer. And then from the right outlet, I'm doing a couple of things to generate impulses. So stash gives us a number that represents what step it's on. And we can just say, hey, each time that changes, give me an impulse. And then we're using that to do 2 things. One is to trigger the ramp, and then the other one is to trigger a little sample and hold that's giving us a random velocity value on that 0 to 1 scale. So That's a simple example of this mc.midiplayer being integrated with some kind of sequencer that we're building in Max. Okay, so now on to kind of, I think, what is really this object's official use, which is using it with VST tilde. To be honest with you, I'm more often than not using it in this fashion, where I just send MIDI, because I don't particularly personally like to host plugins inside of Max. I find it's a little bit clunky. So even if I use a plugin, I'll more often use it in Ableton and just send MIDI over. But if you like to host your VSTs inside of Max, then using them with mc.midiplayer is super simple. You literally just connect the left outlet of mc.midiplayer to your VST tilde object, and now you can trigger notes. And all the same rules apply as far as things with the ramp and the MIDI note and the velocity. It all works exactly the same way. One thing that's kind of interesting to note here is that, like, while this is a sort of Bumblebee style, audio style patch cord, there's not actually a signal here. So if I take like a number tilde object and connect it, you can see we're not getting anything there, and same if I put a scope. I'm pretty sure that all that's happening here is that this connection is kind of just basically telling mc.midiplayer that this is the VST that it should be triggering when events occur. And there's some stuff happening under the hood there. So that's a VST part. And everything else I talk about here, most of the examples will use the MIDI approach, but there's really no difference in terms of the capabilities of those two different sort of styles of output. So you can assume that anything that I talk about going forward works with both the VST and the MIDI use cases. Okay, so let's talk a little bit more about note duration or note length. So I talked just a moment ago about how we can trigger a ramp. We can basically get an impulse, which in this case we're doing with a what object, and then trigger a ramp object, and then change the length of our MIDI notes by just changing the length of the ramp. So down here you can see all I'm really doing is just taking this MIDI event message that we're getting from the second outlet, and I'm detecting with this little bit of patching here the note on and note off events respectively, and then I'm just measuring the amount of time in milliseconds between those two events. And so you can see that for the most part, it pretty accurately fires off those events when it's supposed to, right? And because mc.midiplayer starts the note event when the ramp starts, and it ends the note event when the ramp ends. Now, another thing that you can do actually is tell mc.midiplayer basically to choose a different endpoint along the ramp. So by default, the value is actually set to 0, which I guess is the same as 1, which means that the end of the ramp will trigger the note off. But I can also change that. So I could say 0.5. And you can see here that we're getting values in the 125-ish range. Whereas if I give a value of 1 for this default dir attribute, then it's 250 milliseconds. So it just so happens that a subdiv of 8 of a 0.5 hertz phaser is 250 millisecond increments. So this is two ways to change the note length. I kind of like this approach because it's very clear. It's very obvious exactly how long those events are going to be in milliseconds. But if the way that you want to work is to kind of think about the note length being something that's proportional to the ramps that you're sending into mc.midiplayer, then you can do that. And of course, you can use these two things in conjunction. So you could send a ramp, which is of a certain length, into mc.midiplayer, and then have the note events be proportional to whatever that ramp's length is. That totally works. So, two useful ways to change the length of your MIDI note events. Moving along. So another feature that this object has is called vel curve, which is basically a sort of a unit shaping of the velocities that you send in. So by default, the vel curve is negative 0.75, which means that as I send in values between 0 and 1, which I'm doing just by passing a phasor signal, which you can see represented by this orange line in the scope, I'm sending that into the velocity inlet, third inlet rather, of mc.midiplayer. And you can see that as the note events are activated, and by the way, I'm doing a 30-second note, sort of note pulse with a subdiv object over here, where the mc.midiplayer object is producing MIDI notes that have velocities that are represented by this white signal. So we're basically seeing the velocities of each of those note events that get activated. And you can see here that the velocities that it's actually producing are kind of subtly logarithmic. So with this value of negative 0.75, it's going to generally output somewhat higher velocities across the range than it would if you used a value of 0, which is just linear. So this is kind of useful basically because if you send really low values like, 0.1 into this velocity inlet, very often that's going to result in sounds that are inaudible. So a lot of times you want a little bit of a logarithmic curve there so that you just can hear things a little bit better. So this is just a helpful thing that makes it so that you don't have to do any of this shaping on your own and it's already built in. If I go all the way up to 1, or I'm sorry, down to negative 1 rather, you can see that that logarithmic curve is just a little bit more extreme. And of course, if I go the other way, I'm going to get an exponential curve. So in this case, the output is going to trend more towards sort of the lower end of the spectrum. I think typically the default is pretty good of 0.75, or negative 0.75. And just for fun, I built this little smoothing thing in here so that we can actually really see that, that signal very clearly. Cool. All right, moving along here. So we've been talking about how to actually trigger notes with this object. You send a ramp in. And that is true, presuming that your trigger mode is set to phasor, option 0, which is what we have set up over here in this leftmost one. But there are 2 other trigger modes. So we talked a bunch about this phasor one, or we could say ramp. Just like I said before, the beginning of the ramp means the note on event, and the note end is set by this default dir attribute that we talked a little bit just prior. If you use the trigger mode of edge, it's going to look for just 0 to non-zero transitions. So basically, when the signal goes from 0 to a non-zero value, that's the note on. And when it goes from a non-zero to 0, that's the note off. So this is way more like a traditional gate signal that you might see in an analog synthesizer. And you can see here that I just have created a very simple gate signal. And that's producing the event for me. And then finally, there's this change mode, where basically the assumption is that we're going to patch the note signal. So the same signal that's going into the second inlet will also patch into the first inlet, and then use those changes in values to trigger the note events. So if you don't want to have a separate signal like a gate or a ramp that tells the object when to start notes, then you can use this change mode. The thing with this, of course, is how do you know when the note off is going to be, right? If you send it something and then I just sit here and wait, the way that we actually get the note off is by sending a value of 0. So what I have actually done here is I've used a make note object, which is going to, when it receives a MIDI note event, so we're going to get, every time I click on the multi-slider, we're going to get a note from the left outlet. Sorry, not the multi-slider, the K-slider. We'll get a note from the left outlet, a velocity from the right outlet. This strip note object is just removing any note off objects that this K-slider sends because I don't want them. So I'll just get note ons. And the result is basically just note and velocity values like those, right? Make note will then schedule a note off event based on this duration attribute. So it will receive the 64 and the 89, and it will pass those through from its left and right outlets. And then 250 milliseconds later, in this case, it will send a 64 and a 0. And what I'm basically doing here is just using that capability to silence the mc.midiplayer. I'll show you. Number after 250 milliseconds by multiplying the note value by 0. So you can see if the note is still active, then we're getting a value of 1 to float right here. But when it becomes inactive, then we get a value of 0, which is multiplied by the note value coming from the left outlet of case slider. And then that goes back down to 0, which tells mc.midiplayer to turn the note off. And that only happens if you have this play 0 disabled. So this is the default, this play 0 attribute. I don't know really a use case where you would want to enable this. So basically, if you're going to use trigger mode change, you're probably going to want some way to end the note. And the way that you do that is by sending a signal value of 0. And in order to make sure that that works, you have to have this play 0 attribute be disabled. Hopefully that wasn't too confusing. Okay, so let's get into kind of the hairiest, perhaps like most thorny part of this whole thing, which is polyphony. And we're kind of going to spend the rest of our time talking pretty much about the concept of polyphony. And polyphony is simply when we have two note events that are happening at the same time. So if you have a chord or you have any kind of overlapping notes, that's what polyphony is. And mc.midiplayer makes that possible by allowing us to send MC signals into the object, right? All of the examples that we've been looking at so far, such as this first one, we can only have one ramp at a time, right? Because we have a single channel signal and the note starts when the ramp starts and the note ends when the ramp ends. So if we want to have multiple events happening at one time, we would need to be able to have multiple ramps. And MC allows us to do that by allowing us to have multiple channels flow over a single patch cord. So here I just have two ramps that I can generate. I just have a 2-channel signal, and I can have 2 ramps that flow at the same time, and you can see them down here represented on this scope. The one on the left is the red one, and the one on the right is the white one. And if we come down here, you can see that we're getting both of those events on channel 1. And the reason that we know that is because when we send the MIDI event message, I'll talk about this pdm.midi event in a second, but if we just assume the MIDI event is going through that same little bit of patching with the route object and the iter object, and going into the MIDI parse object, that we're getting the MIDI channel from this second to last outlet. So you can see here that we're getting these messages, and if I actually come over into the console and look at them printed, and I click the one on the left and then I click the one on the right, you can see we get the first one, which is a MIDI note 60 on at 127, so maximum velocity. And then we get the second note, which is MIDI note 61, and then after that we get the note off for the first one and the note off for the second one, right? So we have 2 separate notes that are coincidental that are both flowing to MIDI channel 1. By default, this isn't exactly how the object works. By default, this chan mod attribute will be set to 16, which means that the object is basically going to try to distribute concurrent note events on different MIDI channels. So now if I, having changed this chan mod attribute to 16, which is the default, you'll see that it's actually going to send that second event on MIDI channel 2. And if I had more channels, it would try to use those channels. So if you have a synth that expects this, and in fact, if you're using MPE, very often that is the case, that it's expecting different note events to be on different MIDI channels. But typically for standard MIDI, you don't need to do that. You can just send everything on one channel. So very often when I use this object, I'll just set it to chan mod 1, which basically constrains the number of channels that the object will try to use to distribute note events. So at 16, it's basically going to say, okay, I have 16 channels available, and if I have 16 notes going on at one time, I'm going to be using a different channel for each of those. If I set the value to, say, 3, then it's only going to try to use the first 3, so channels 1, 2, and 3. If you wanted to be able to send all of the messages only on one channel that was not channel 1, then you need to do a little bit of trickery, and that's where this pdm.midi event patch comes in, which is an abstraction that I've included in this package, and you can download. I won't dive into the patching here, but basically what's happening is it allows us to kind of add an offset to the MIDI note. So right now with chan mod 1, we're going to send everything on channel 1. But if I wanted to say send things on channel 2, then I would just send a message chan offset 1 to pdm.midi event, which is basically going to just add 1 to the MIDI channel that we output. So instead of sending on channel 1, we'll be sending on channel 2. Or if we wanted to send on channel 4, we would say chan offset 3. And so now we're sending on channel 4. So that's a way that you can basically control exactly what MIDI channel you're using for those messages that you're sending out of max to synths or DAW or whatever. So this capability of being able to handle polyphony using MC is kind of cool. The issue with it is if you have a sequencer that, say, is producing lots of very rapid events. So say you have some process where you have a bunch of impulses that are being fired off very rapidly, and those are going into, say, ramp objects. And the time in between two impulses is not necessarily always longer than the length of the ramps, right? So you may have overlapping notes. How do you actually make it so that all those different ramps are on different MIDI channels? As far as I know, there isn't a great solution for that. So I did make one here. Basically, what this does is, if we have like an ultra fast pulse of, or not even ultra fast, but just a fast enough pulse of impulses that is longer than our ramp times, then it will distribute those ramps across various MC channels, 16 MC channels, and it will do the same for the corresponding notes and velocities. So if I start this, you can see we're getting this really rapid pulse here of impulses. And then over here, I have a note length set. So there's basically, I've made basically a ramp object internally inside this gen patch. And we're generating 1 second or 1,000 millisecond note events. And by looking at the meter here or the scope, these are showing the same signal. You can see that we have ramps that are concurrent, that are happening at the same time. And those are happening on different MC channels. And then over here, on the right-hand side, we're making sure basically that we associate the proper MIDI notes and velocities that we put them on the right channel so that they correspond with the note event that they actually go with. So this is like a solution. As you can see, it's a little clunky, right? I mean, there's a bunch of gen patching in here. There's a bunch of packing because you can't, as far as I'm aware, and also I'd love it if somebody knows a better way to do all of this, jump in the comments and let me know. Like, how do I get from a single channel signal into MC signal, right? What I've had to do is basically create like a 48 output gen patch with 16 for the ramps, 16 for the notes, and 16 for the velocities, and then send those into mc.pack objects. So not the best solution, but the only way that I could really think of to actually get this mc.midiplayer kind of approach to polyphony to actually work with the kind of sequencers that I tend to make. So this kind of got me thinking towards what we could do as an alternative. And what you could do, pretty simply, is not use ramp to generate the node events, but rather just use good old-fashioned make note. Because make note, which we looked at earlier, but takes in a note and a velocity and a length, is actually capable of managing polyphony, right? So if I send it, a value of 60 to the node inlet, and I send it a value of 100 to the velocity inlet, and I have the note length set to 1,000, and then I send another node and velocity pair, it's going to make sure that the node off events occur at the correct time. It will schedule those correctly. So what then all we need to do to get that to work is to convert the signals that we're getting from the upstream sequencer, which in this case are just note and velocity signal values that we're getting from stash, convert those into integers, which we can do with snapshot. So what's happening here is we've stored these lists of notes and velocities inside stash. And if you're not familiar with stash, you can watch a video on it, links up above. We pass it into snapshot object. And we bang those snapshot objects each time we have a new node event by taking this write outlet of what. There's also a video about what. I'll put the link up above. And then we turn the result, which are going to be floats, into integers, and then we send them into make note, and make note schedules things. So not a totally signal-based solution, but a pretty good one because it doesn't require us to do all of this nonsense in order just to get simple polyphony. But there is one issue that I discovered, and I do not really know how to solve it within Max. I found a solution, but it's a little bit weird, and I'll show you in a second. But the problem is that some of the events tend to be repeated. So I've printed several of the outputs of this system, and you can see right here, 6429, 6429, we're getting that twice. Same with 6094 and 6094. I don't really understand why this is happening, to be perfectly honest with you. I think it's something to do with how Snapshot is working with these bangs that I'm sending it. But there's some problem here where it's not actually sampling where I want it to. I couldn't figure out how to fix this other than to actually build the exact same patch inside of Rainbow. So now I'm on a new tab where I have two things. On the left-hand side, I have the same patch as the prior one. So we're using Snapshot, the MSP version. And then on the right here, I have basically, I'm sending an impulse into this Rainbow patch, as well as the velocity and the note values. And then inside, I just have an edge object, which is turning that impulse into bangs, and then snapshot objects, and then I'm just sending those to the output. And for some reason, and I can't tell you the reason why, we don't get those repeated events. So if we look over here, like we find a repeated one, like 6220, 6220 right here, we don't get that with the Rainbow one. So the Rainbow one is more accurate for some reason. Although I guess that's fine because Rainbow works and is great. And because we're using Rainbow, we can also just make an external so that we don't have to think about these problems ever again and just have them solved. So I went ahead and did that. I basically made a Max object that does pretty much what we're doing in this little rainbow patch with a few improvements that I'll show you in a second. And I'm providing it for all of you because I know you don't all have rainbow. But you should be able to use this external. So basically, here, side by side, we have on the left the rainbow patch, which is pretty much just an upgraded version of what you saw on the other tab. And the main kind of improvements are, number one, we have parameters, default note, default velocity, and default duration. So I kind of borrowed the same names that mc.midiplayer has, where if you choose not to use some of the inlets, like if you don't actually patch anything into the node inlet or the velocity inlet or the duration inlet, then these parameters kind of define what those default values are going to be. But if you send some signals into those inlets, these defaults are overridden. In addition, we also construct the MIDI note here inside of the rainbow patch and inside of the external. So we have the snapshot bit that you can see here. We send that into a make node object, and then we actually just convert that into MIDI and send it to the outlet of the object, just as regular old MIDI, which is really cool. So all we have to do is just patch the output of the object straight into a MIDI out, and that will send MIDI. So, like, pretty awesome. Let me show you the Polyphony in action. Right, so even if we're sending these really long node events that are 788 milliseconds long, and we're firing off lots of them, the synth that I have sitting here in Ableton has 6 voices. I'm using Wavetable, and it can play all 6 of those voices simultaneously. So this object you will find in the GitHub. The link is going to be down below. And if you're a Rainbow user, this is also saved and you want to mess around with it, you can totally do that. But if you're not a Rainbow user, or you are and you're just happy with what this thing does, then you can use this. So, this pdm.midiplayer, in a lot of ways, it's kind of like a less capable version of mc.midiplayer. It takes impulses. It doesn't do the whole ramp thing. You can set the duration either by sending a signal into the last inlet or by setting a parameter value. It doesn't work with VST tilde, but it does send MIDI and it does handle polyphony very elegantly. So you kind of have an option when you're working whether to use this or whether to use mc.midiplayer. All right, I think that's all for today. That was probably a long one. Let me know if you have any questions. If you're enjoying these videos, please like and subscribe. And I'll see you next time. I don't actually know what we'll do for the next video. If you have a preference, get down there and let me know. We could, I don't know what we'll do. I'm sure there's other ones that are interesting, but yeah, if you care, get in those comments. All right, thanks. Bye.